Hello there, friends and neighbors. Now I'll show you an example of how to use a spreadsheet to do an apportionment exercise. And of course, I could cheat-ish, it's not really cheating, but I can go download the apportionment spreadsheet that is already available in Canvas and use that, and that would be okay. It's right here. The 6 states apportionment will work. But I'm going to try doing it from scratch because it's not too hard to do something simple like the Jefferson, or the Hamilton method is even easier. I'll do Hamilton. Okay, so I'm going to open up and, I don't know, let's say we've got hospitals. We've got, I don't know, hospital A, B, C, D. And for each hospital, we've got a number of patients they can house. And let's say they can house 340, 260, 138, and then 75. Okay? So we're going from high to low for how many patients they can house. And what I want to do is the house size, I've got incubators that I need to apportion. And that's H. And H is, let's make H be, let's say I've got 6 incubators that need to be apportioned among these 4 hospitals. And I'm going to do so using the Jefferson method. That is the method of largest fractions. Okay, so what I need first is the population size, P, and that's equal. SUM means add them up, it's the sum, open parenth. I'm going to add up all of the populations for each state, which of course is a hospital. Enter. That's 813. Now I need to get the standard divisor, which is the house size divided by the population. Oh, it's the other way around, isn't it? It's the population divided by the house size. That's the standard divisor. So now for each state, I'm going to give their initial quota. Their initial quota is equal to their house size divided by the standard divisor. That initial quota is 2.509. And I do the same thing for each. Equals the population for that state divided by the standard divisor equals state population divided by standard divisor equals state population divided by standard divisor. And just to confirm that this works, I'm going to equals sum, add up all of the initial quotas. Hit enter. And there are 6, as there need to be 6. I'm going to copy this and paste it here because soon I will be giving their initial allocation. We start with the lower quota. That's what we give actually for all the methods. We don't always start with lower, but we start with lower quota for Hamilton. So the lower quota for 2.5 is 2. The lower quota for 1.9 is 1. The lower quota for 1.01 is 1. And the lower quota for 0.55 is 0. Okay? And there's a formula to do that also, but that's a little bit beyond what I really can expect from this level of a class. There's an integer function. Why not? Equals int means integer, and that does it for you. That's a shortcut way of doing it. Use the int function. Okay, so you'll notice that it adds up to 4. I'm going to highlight that in yellow. That means we have not apportioned enough. So their final allocation, their final apportionment, is to round up for the, in this case, 2 states with the largest fraction. So I'm going to start with my 2100 2110 and go up for whoever has the largest fraction. I'm also going to copy my summation, copy, and paste it here so that it's going to add up the result. When it adds up to 6, I know I'm done. So the largest fraction is 0.919, and that is Hospital B, so they get their upper quota. One other one goes up. The next largest fraction is 0.5535. So Hospital D, they're going to get their upper quota, and now I'm done. This is an example of how to do an apportionment with the Jefferson method using a spreadsheet. Next, in part 6,